So we're just going to do 14 here. And it's talking about degrees and turns and zeros and then behavior and all that good stuff. So let's start with the simple stuff, the pattern. You know that if you have ax squared plus bx plus c, so if it's to the second degree, you already know what this looks like. It's going to be some form of parabola, right? All right, which implies it has two zeros, x equals anyway zeros, and two zeros, and therefore the degree is 2. So in this case, the degree is 2, and you have two zeros. Okay, x equals 0. So you have an x and you have a 0, of course. And then as far as turns are concerned, right here, this is to the second degree, but it only has one turn. So you always have one less turn than the degree. So here, you're going to have one turn. All right, so taking it, that's just a simple process here. So here, our degree is 5. So we know that the degree is 5. One less for the number of turns. So it's going to have 4 turns. If the degree is 5, that implies there's going to be 5 zeros. And then the end behavior, get my notes here. Here is a summary of the end behavior. And the end behavior is dependent on the degree as well as the leading sign of the coefficient. So in this case, let's just recap all of those. Okay. If the degree is even, all right, and the leading coefficient is positive, then it's going to rise to the left and rise to the right. All right, so it's going to rise on the left, whatever it is, and you're going to be rising on the right. All right, next one. If the degree is even and the leading coefficient is negative, all right, it's going to fall to the left ultimately and rise to the right. If the leading degree or the degree overall is odd and positive, keep the color straight here, odd and positive, then it's going to fall to the left and rise to the right as well. Fall to the left, rise to the right as well. And the last one is if it is odd and the leading coefficient is negative, then it rises on the left and falls on the right. Rises on the left, falls on the right. Excuse me, this one, yeah, falls on the left, rises to the right, falls to the left, and rises to the right. I knew one of these was wrong. This one's wrong. Okay, if it's even, if it's excuse me, yeah, if it's even, okay, so if the degree is even, you're going to be starting and ending in the same direction. If the degree is odd, you end one way and start one way and end on the other. That's why I was hesitating. So taking a look here, if it's negative, it's going to fall to the left and fall to the right. So your trajectory is going to look like that. And if it's positive, it goes up. So if your exponent is even, you start and end in the same direction. And of course, if it's positive, you're going up and up. If it's negative, you go down and down. If it's odd, you start one direction and go the other. And if it's odd positive, you start down and rise to the right. Just think positive slope, right? Let you read from left to right, left to right on a graph. And then if it's odd, it goes negative, it's going to have basically a negative slope. Again, we read graphs from left to right. All right, so your end behavior for this particular one, all that to say, it is positive but odd. So it is somehow, it's going to, you go to graph this, it's going to fall to the left and end up rising to the right. And of course, it is going to turn 4 times here somewhere, like right, 1, 2, 3, 4, and then up that way. And then so part of your deal is to find the zeros, of course, every time it turns. 1, 2, 3, 4. There's going to be a 5th turn there, a 5th zero. 4 turns, 5 zeros. So now to find the zeros. Grab that, we're going to add that to a new page. Okay, this is going to take us about 10 minutes here because we know already there is a total of 5 zeros. How do I know there's 5 zeros? Because I have an exponent of 5. So there's going to be 5 zeros total. So we have to account for them all. All right. So step number 1, group and factor stuff out here. Find all my notes. Okay, so step number 1, I am going to simply take out an x. Why? Because I can. So here's an x. Take it out, and we have x to the 4th minus 5x to the 3rd plus 9x to the 2nd minus 7x to the 2nd plus 2. Okay, that is step number 1. Now I have this giant, long monster problem, and I can't really group anything because it's an odd number. And so what you're going to do is find your rational potential roots and do long division. So just as a reminder, what your rational roots are, that's going to be P, which is factors of the constant over Q, okay, which is factors of the leading coefficient. All right, leading co. So here, taking a look here, what is our P here? And our P is 2. So that's going to be plus or minus 1, and plus or minus 2 would be the factors of P. And Q, our leading coefficient, of course, is positive 1. So we have plus or minus 1. So if I put P over Q, you basically get any combination of that. And that means you're going to have plus or minus 1 and plus or minus 2. That's all the possibilities. So when you're faced with that many possibilities, it's just easy to test one first, just positive 1, and kind of see what happens here. So we're going to put 1, positive 1, because that's easiest to work with. We're going to pop it in here. I'm going to just see if 1 is a root. All right, so we're just testing here. So I pop 1 in there, and that's going to be 1 times 1, right? And I pop 1 in there, so that just makes that 5, because technically that's 1. 1 goes there, so I'm going to do plus 9, okay? And times 1, I'm going to start ignoring that. And minus 7 times 1, so that's just 7 plus 2. And you see if this grouping works, okay? 1 minus 5, negative 4, plus 9, minus 7, plus 2. Let's keep going. And of course, keep going. And this is going to be 5 minus 7, plus 2. 5 minus 7 is negative 2, plus 2. Oh, looky there. It's a 0. So we just identified 1 as a potential 0. So to do that, we are now going to test it and divide this whole thing out. With our root is x equals 1. So we're going to use the factor x minus 1 to divide it out and simplify. So I'm going to take this right here, I'm going to do this in yellow, and x to the 4th minus 5x to the 3rd plus 9x to the 2nd minus 7x to the, excuse me, it's 9x to the 3rd, right? 9x to the 3rd. Taking a look up here. No, it's x to the 2nd. It's 7x to the 1st. That's where I dropped the ball. It's to the 1st. And plus 9x to the 2nd plus 7x plus 2. And we are going to divide that by the root x minus 1. Okay. All right. I'm going to color code this here. I'm going to start with simply, I want x to the 3rd. Where is my notes there? We start with x to the 3rd. And we go like this. Imagine kind of like a foiling thing going on here. So I'm going to have x to the 4th minus 1x to the 3rd. Okay, that cancels. And I'm going to end up here with negative 6x to the 3rd. Okay, a little mistake here. Got my mistake here. Technically, we are subtracting this entire thing. So I forgot to distribute that negative. So that makes that a positive. There we are. And so we're going to end up with, this is going to be negative 4x to the 3rd. I'm going to bring down the 9x to the 2nd. And so our next step is to minus 4x to the 2nd. And again, you're distributing like this. And that is going to get us negative 4x to the 3rd. Double negative makes a positive, plus 4x to the 2nd. And once again, the trick here is you got to make sure you distribute because you are minusing this entire entity. That's the trick. So that becomes positive. This becomes negative. These cancel, and you end up with 5x to the 2nd. So we're going to keep going here. And so now we're going to have plus 5x And we're foiling. And that's going to be negative 5x. Oops, I forgot to bring something down. Hang on. Got to bring down that 7x plus 7x. Got it. Okay. So foiling. And we have 5x to the second minus 5x. Once again, we're subtracting the entire thing, distribute. That makes that negative, that positive. Okay, I dropped a sign here. This is negative. It's negative, which makes this down here. Okay, that's going to be negative, makes that positive. So I have cancels, and this is going to be negative 2x. Bring down that positive 2. Great, let me shrink this back. And last but not least, we're going to make that cancel, we're going to go minus 2 here, minus 2. Again, distributing like so. And we end up with negative 2x plus 2. But we're subtracting that entire entity, so you have to change the signs. And they cancel completely. Woohoo! All right, so all of that is to get this secondary component. So let's keep track of where we are at. Remember, there's a total of 5 zeros. So our original is x, there's 1. And now we also know that x minus 1 was a root. All right, and now we have this entity to deal with, x third minus 4x to the second plus 5x minus 2. Okay, coming over here, we're going to test to see if 1 is a root. Okay, so here's our test. So I'm just going to pop in 1 wherever there's an x to see just if we're lucky and we get a 1 here. So I'm going to pop in a 1 there. 1 times 1 times 1 is 1. So minus 4 times 1, so that's 4, plus 5 times 1 plus 5, minus 2, at negative 3 plus 5 minus 2. And so that's negative 3. And of course, that's going to be positive 3, 0. Woohoo! That's a 0. So we know that one of our factors that creates a 0 is 1. So we can do this again, take this entity, and we're going to divide by x minus 1, right? Because if x is 1, to turn it into a 0, it's x minus 1 equals 0. That's where that comes from. All right. Keep that in mind there. Now we're going to do a giant division again. All right, x to the third minus 4x plus 5x minus 2. We have x minus 1. Let's make sure I don't mess with the signs again. Oops, we just did. It's a square there. Here we go. Double check my sign so I don't mess this up. Good. Okay. Ready? Here we go. Step number 1, I am going to start with x squared. And that's going to be x to the third minus 1x squared. Once again, because we are minusing this entire entity, you distribute. That makes this negative, that positive. That cancels. And we are going to end up with negative 3x squared. Okay. Next, so we're going to minus 3x. So that's going to get us, we need to bring down the plus 5x. So this is going to be negative 3x squared plus 3x, minusing this entire entity, distribute, that makes that positive, makes that negative, that cancels. And so we are going to end up with, running out of colors here, positive 2x minus 2. So now we're going to add 2. We have 2x minus 2. Subtract and minus that plus, they both cancel, we get 0. Yay. So we just found that x minus 1 is yet another factor again. So we end. There's that right there. So let's kind of pull down so you can see everything in its original form. So we had our original x, and then we figured out that x minus 1 is a factor, and we have figured out again that x minus 1 is a factor, and we are left with this right here, which is x squared minus 3x plus 2. You should be able to Xbox this quite easily. We have 1 times 2, and we have a negative 3. So we know we have a double negative here. We have a negative 1 and a negative 2. That should be pretty easy. Adds to negative 3. So we have here x minus 1, x minus 2. So our total number of zeros, you should be able to see this now. X, just keep the color straight here. X minus 1. I meant to change that to blue. Okay, x minus 1. And then x minus 1. Okay, so you count your zeros. We have 1, 2, 3, 4, 5 zeros. So that means we're going to, it falls to the left, and it's going to take 4 turns. 1, 2, 3, 1 turn, 2 turn, 3 turn, 4 turns, and then go up. We know that. And we know in the process, we are going to cross the x-axis 1, 2, 3, 4, 5 times. So we know that's ultimately what it looks like. What are our zeros? Well, that's x equals 0, comma. We have x equals 1, 3 times. Okay, so technically there's going to be 3 instances of it crossing. And then we have our last one, of course, x equals 2.